I milled some stands for a gantry, and now I'm marking a line for y-axis, and I'm doing it this way. Yeah, I have vertical calipers, and I'm just scratching it along on the table. So that part of the surface plate seems to be quite flat. So I moved it to there, and I'm marking it from here. And now I'm gonna mark the same from the top. So I have like this and to here. So that's gonna be that spot. I'm gonna unlock it and move it up. Wow, I won't move it up. Okay, be back. Alright, I flipped the scratching point, and now I'm doing the top edge. So it's just moving it a couple of times. Okay, so it's done. Line is perfectly visible. So now I can, you know, put that thing like this and drill the holes every 6 centimeters. And I'm gonna do it off the table. Hey, so quick update. I made those things. So I mill it, and I make like a registration groove, so it would be easier for me to have 90 degrees to the table, because that's 90 degrees. I mean that's parallel, and that would be 90 degrees. So I have another one here, and in the gantry, I had the problem how to mark it, because I have this, right, and it's every 6 centimeters, and it's really hard to mark that thing. So, because I'm lazy, I put it on a laser, and I'm gonna mark on the laser. So here I have a program, so it will do like straight lines, like something like I was trying to do here. But it will be a bit longer and a bit deeper. So I marked this on to the surface plate, and now I'm gonna mark every 6 centimeters like that. So here it goes. I'm gonna press start. I haven't tried that, but origin and start. Isn't it easier? Yeah, I think it is. Okay, so as you can see, I already installed rails on the gantry, and now I'm gonna be mounting gantry to this here and there. So I drill the holes, and yeah, so that was the insert, which is perfect. Come on. Okay. So that's the insert. It's threaded through, and that wouldn't stick well because it's pretty smooth. So I a bit destroyed them. So I ran them on the belt sander, and I made like grooves and scarred the surface, so the glue has a better surface to stick. And the glue, I discovered that DeWalt, that's the polyester glue, and it's for anchoring, and it's much better than JB Weld. JB Weld it's too soft, and so sharp. That one dries in more or less, how many degrees do we have? Around between 20 and 29, 6 minutes, and the full cure time 45 minutes. And it's actually slower than Sika, because I tried the Sika as well, and the Sika was like 3-4 minutes, so it was really too fast to even mix it. Okay, so I have my squeezy gun, and I'm gonna try to squeeze. Okay, I haven't been using it for a while. Jesus, it's definitely too much brown. Okay, now that one is coming up. So I'm still eyeballing it, but now I know how to eyeball it, so, or what kind of color it should be. It's something around there. I'm not gonna use it too much, just try to mix it really well. And because the time is an essence, I'm gonna try to do it quick. Fill it up pretty well. Okay. And I guess I need the screw. Where I have the screw. Okay, so I'm gonna put the screw in. Oh please. And I'm gonna glue this thing as well. Trying to fill the holes. So when it's in, it will bind with the wall, and because of compression, it won't be able to pull out. I should show you gluing on the previous videos, but I'm showing you it now. I really don't have much time recently, and yeah, my videos are kind of long anyway, so there is no really point showing you how to glue inserts, 15 times during the process of building that CNC. I think once it's enough. I'm kind of mumbling right now because I can't really focus on two things at the same time, doing something and talking with the sense, but I guess you understand. Okay, I'm gonna use the next one. Okay. That thing is done. I turned it a bit to level it, and I just weighed it. That's 34 kilograms. So yeah, I'm gonna put it on off the camera, so be back soon. Okay, here it is. I had some more time to work on the thing, and so far it looks like this. So I spend most time doing the Z-axis. It's still work in progress, and possibly it might be a test piece. It's an inch thick piece of aluminium, bolted to the rails. I will have to put the lead screw, and yeah, I guess that's gonna be interesting. And pretty much front plate, and it's done, and something to grab on the grab screw. And this is how I made the gantry. And I did kind of pre-square that thing, so by loosening those screws and screws on the bottom. So when you lose screws which hold the sliding blocks, you can move it left and right a bit, and undoing those you can adjust that one, and this way you can move it gantry left or right. Here I kind of did an experiment for the side screw for y-axis. So screw gonna be here, mounted to the back and to the front with the plate. And what else? Yeah, I kind of discovered interesting problem when I was trying to how to say, when I was trying to make the rails parallel to the surface plate. I was trying with one, and that was a bit not that great of an idea, because that rail is not that precise. And when I had the dial indicator on the block, and the block was here, when you screw that thing in, and the bottom of the linear slider, it's grounded not really flat. It's like it has one side higher or the other one. It was moving the gauge up and down, and and that was a bit frustrating, because as soon as you screw something, it goes up or it goes down. So to avoid that problem, I put 2 rails, and I was trying to adjust them 2 at the same time. So I don't wanna say I tightened them really well. I just have them screwed in so you can still kind of move it up and down. And I started from that end, and I was working my way to the left. And yeah, and you have to. So I did drill a hole, 2 holes, one there and the other one there. So I can adjust, you know, like adjust this screw, and then do some screws over there and something in the middle at the same time, while those blocks are holding it like pretension the linear rails, so everything is kind of squarish, moreish aboutish. And once you do those, you move one next, and you do, you know, this one, and then you move next. It takes really long time to actually do something with it. It's lots of screws and lots of, you know, measurements with this. And so far I'm around, I think, 20 microns, more or less. Here I have a bit high, I think, and it goes back to normal. And along, it's, I guess, also around 20, maybe 10, maybe 15, something around there. Yeah, I'm not too terribly disappointed with it, I have to say. It's yeah, it's holding on really well. I might try to maybe a bit condition the plate after such a long time of using it, because the surface plate has around, I think, 10 microns, especially here. It goes down, but I'm not entirely sure if I even be bothering myself doing something with it. We're talking here, how many microns? Splitting a hair into 4 or 5, 5, which is like over the whole, you know, surface, whole range of the machine. I don't really think it's that dramatic, you know. Do an experiment. I guess you're wondering why this gantry, actually the z-axis, it's so wide and big and so on. Those sliding blocks, they have a play this way, and pretty much every way they have a play. So I'm trying to put them apart to divide that play over the distance. So if they are close to each other, so let's say one has 10 microns play and the other has 10 microns play. So when they are like together, for the sake of argument, they will divide that play by a half, which is, you know, 5 microns. but when I spread them apart more, the distance plus the play will cause the whole thing to have much lower angular plate. So that's why everything is so wide. So like that way, you know, it doesn't move, and that way, you know, so you will have some play, but because it's so wide, it won't really be much. And yeah, so now I'm gonna get the camera closer, I guess. So I'm not gonna be, you know, playing with the finger and, you know, trying to push it and show you how much it's gonna move, because you don't know how much pressure I'm gonna put. So that's why I'm gonna use this. Yep. That's a granite surface plate, a bit smaller, and I believe that one weighs 22 kilograms. I'm gonna move the camera closer, and I'm gonna put that block over here. So maybe I'm gonna put it out. So I'm placing it on my Z-axis. Okay, I hope you can see it. And now I'm gonna lift that granite block. Okay, it's up. As a confirmation, I put it here. Yep, it's here. So it moved what, 3 microns or something? Check it again. Okay, it's 0. Moving it up. And it moved 2 microns. Yep. So, and yes, what happened if I'm gonna put the granite block on the gantry? I guess I can show you as well. Okay. So alright, it's 0, right? I hope you can see it. And now I'm gonna lift it up and put it in the middle. Okay. What, it's below now? Even the vibrations are changing it. Okay, it's 0. And granite block, it's resting on the gantry. And you can see there. And now I'm gonna lift it. Okay, I take it out. I don't know, maybe if you saw if something twitched. As you can see, I removed it. It's not on the top anymore. That's why I went with granite, because I don't have to worry about you know, too much play. And yeah, I hope you kinda getting the idea what I'm trying to achieve here. And I hope you liked it. Did you? And yeah, I'm gonna be updating you soon, I hope.